In this video, we're continuing with 4.2, but this time we're going to learn how to solve when the graph's not given. So you're going to have to graph by hand. So your first step when that happens is to set your equation equal to 0, because then when you're looking at your graph, your zeros or x-intercepts will be your solutions. We're going to start by finding the vertex using the formula x equals negative b over 2a. If you can get that x from the vertex, then you can find at least the 5 values that center around it, with a vertex in the middle, and that'll more or less show you what your parabola is going to look like. Once you have your parabola sketched with at least those 5 points, you can identify your x-intercepts because those are going to be your solutions. So here in example 1, we're going to solve using the graphing method. Here it's equal to 0, so I can already start using my formula, x equals negative b over 2a. For here, my a is 1, my b is negative 6, and my c is equal to 5. So I'm going to plug in negative 6 for b and 1 for a. And now I got my x from my vertex. So what I'm going to do now is I'm going to make a table of values with up to 5 rows. And I'm going to put this 3 in the middle because it's going to be part of my vertex. And your vertex is the middle of your parabola. Now I'm going to find the numbers that center around that. So after 3 would be 4, 5. Before 3 would be 2, 1. And I'm going to plug these into the formula x squared minus 6x plus 5 to figure out my y values. So all these numbers I'm going to plug in for x to get my y values. So here I get 1 minus 6 plus 5, which is 0. Next I'm going to plug in 2. If I work that out, I get 4 minus 12 plus 5, which is negative 3. And I'm just going to continue plugging in my values for x. So like here I'll get 9 minus 18 plus 5, which is negative 4, and I'm just continuing this process. So you're plugging in for x, working it out using PEMDAS, and then once you get your answers, you write them in the y column. Now I want you to notice something that happens here. Again, we put our vertex in the middle, so 3, negative 4 was our vertex. If you look carefully, the numbers start to repeat around that. So we have negative 3, 0, 0. The reason they repeat is because our parabola is symmetrical. So later, you don't really have to do more work. Once you find your first 3 values, you can start to repeat the points around that. So I'm going to go ahead and graph this. I have my first point at 1, 0. Then I have a point at 2, negative 3. 1 at 3, negative 4. 4, negative 3. And 5, 0. Once you have your graph done, we're going to solve, and that's by looking for our x-intercept. So this one actually has 2 real solutions because it has 2 x-intercepts. One of them's at 1 and one of them's at 5. So my solutions are x equals 1 and 5. Those are the 2 numbers that if you were to plug them in for x in the equation, would give you 0 as your solution. Our next problem, if you look carefully, it does not equal 0. So our first step is to make it equal 0. So I'm going to do that by moving negative 6 to the other side. Remember, when you move something to the other side, it changes sign, so it becomes positive 6. Once you do that, there's nothing left on the right side, so now it's equal to 0. So now I'm going to label my A, which is 1, my B is 4, and my C is 6. And I can plug into the formula, x equals negative b over 2a. So plugging in 4 for b, 1 for a. If I work that out, I get negative 2. Now, your next step is to make your table of values with these 5 points. And then our negative 2 goes in the middle because it's part of the vertex. So again, that negative 2 that we got here, we're putting that in the middle. For this one, we're using the new formula we wrote, which was x squared plus 4x plus 6. Don't put minus 6. You have to put one that you got when you changed it equal to 0. So our negative 2 goes in the middle. Around negative 2 would be negative 3, negative 4, negative 1, and 0. So again, like we learned earlier, work smarter, not harder. We know these are going to repeat, so we can choose to find negative 4, negative 3, and repeat those with negative 1 and 0, or vice versa. So I'm actually going to start from the bottom up here. So just because I know 0 is easier to plug into. So here I know these zeros cancel, I'm left with 6. Next I'm going to plug in negative 1. If I work that out, it comes out to 1 minus 4 plus 6, which is 3. Next I'm going to plug in negative 2. So this comes out to 4 minus 8 plus 6, which is 2. And I know these are going to repeat, so I'm not going to work them out. You can if you want, but you don't have to. Because I know the 2 is going to be around the 3, and then after the 3, there's going to be a 6. So I know those numbers are going to repeat. I don't have to do that extra work. So now I can start graphing. My first point's at negative 4, 6. My next point's at negative 3, 3. Then at negative 2, 2. Negative 1, 3. And 0, 6. My next step after I have my graph is to look for the x-intercepts. But this one doesn't have x-intercepts. It does not cross the x-axis. So since it does not cross the x-axis, this one actually has no real solutions. Because again, your solutions would be your x-intercepts. We're going to do this one last time. So in this last problem, again, this one doesn't equal 0. So what we're going to do is we're going to have to move negative 4x to the other side. When we do that, it changes to plus 4x. I'm also going to have to move negative 1. When I do that, it changes to plus 1. So now that there's nothing left on the right, it equals 0. My next step would be to find the axis of symmetry. So I'm going to use the formula negative b over 2a. Here my b is 4. My a is also 4. So I get negative 4a's, or negative, if I write this as a fraction, 1/2. If you want to write it as a decimal, it's negative 0.5. I'm going to write it as a decimal for now. So now I can make a table with 5 values. And then negative 0.5 will go in the middle. You do not have to use decimals for your other numbers. You can use whole numbers. So I'm going to do the whole numbers that center around negative 0.5. So before that would be negative 1, or it's between negative 1 and 0. So negative 0.5 is between negative 1 and 0. And then negative 1 is before negative 2. 0 is before 1. So I can use whole numbers. It's okay. Don't freak out if you get a decimal. And now I'm going to plug this into the expression we got here. The 4x squared plus 4x plus 1 to get my y values. Again, I want to work with numbers that are easier, so I'm going to start with the 1 down here. And if you do the math there, you're going to end up getting 9. So next, I'm going to plug in 0 everywhere I see an x. Remember, if you have a 0, it's easy because these cancel. We're left with 1. Next, I'm going to have to plug in negative 0.5 everywhere I see an x. So here, negative 0.5 squared would be positive 2.5, or actually, would be 0.25. So we're going to do 4 times 0.25. And then 4 times negative 0.5 would be negative 2 plus 1. 4 times 0.25 actually ends up being 1. So I have 1 minus 2 plus 1, which ends up equaling 0. And we know these numbers are going to repeat. So after 0 would be 1 and then 9 again. So now I have enough information to do my graph. Remember, this was our vertex. That's why we put it in the middle. So my first point's at negative 2, 9. Then I have a point at negative 1, 1. At negative 0.50. At 0, 1. And at 1, 9. Once you have your graph sketched, you want to look at your x-intercepts for your solutions. This one has one x-intercept, and it was at negative 0.5. So our solution for this problem is negative 0.5. In other words, there's only one real solution here. There's only one number that if you were to plug it in for x, it would give you an equation that makes sense. So just to summarize the steps, make sure your equation equals 0. Use the formula x equals negative b over 2a to find the x from the vertex. Once you got that, make a table of 5 values. Put that x in the middle because it's your vertex. Your vertex is the middle of the parabola. Put the numbers that are around that. You can use whole numbers. And then plug into the equation or expression that you started with. Once you get your y values, you can graph it. Once you have your graph, all you have to do is look for your x-intercepts or your zeros, because those are the solutions to your equation.